Yes, good.
Good evening.
Yes, good evening.
Yes, sir. कुछ मतलब वेट. हाँ सर. यस सर, बहुत दिनों बाद.
Yes,
मतलब 1 वीक मतलब 1 वीक डिसकंटिन्यू हो गया था. मतलब तबीयत अभी भी थोड़ा मतलब सर्दी वगैरह है. मतलब हीट के कारण हुआ है ये.
अच्छा,
हाँ सर.
क्या प्रॉब्लम क्या आ गई, क्या क्या हो गया था?
मतलब सर का दर्द था ऐसा. और क्या बोलते हैं उसको, थोड़ा तबीयत मतलब फीवर भी हो गया, इसलिए सर.
जब फीवर हो गया, वो आप घर पे गए थे ना, तो मुझे लगता है ट्रेवल के कारण ऐसा हुआ है क्या?
हाँ मतलब गर्मी के कारण मतलब ट्रेवलिंग मतलब एक वन डिस्ट्रिक्ट से एक डिस्ट्रिक्ट में जाने में मतलब बहुत उस बाहर बहुत क्या हुआ था, प्रॉब्लम हुआ था सर.
गर्मी बहुत है।
मीटिंग. हाँ सर.
यस, लेट बी स्टार्ट बेसिक. इंट्रोड्यूस योरसेल्फ.
यस सर. सो माई सेल्फ उत्पल कलिता एंड आई बिलोंग फ्रॉम Guwahati city of Assam, Northeast, and I am currently working as a lecturer at Government Polytechnic College in Morigao, that is Morigao, Assam, Morigao district of Assam, and I have pursued my master degree from Northeastern Hill University in 2019, and I have done my graduation from Guwahati College in Guwahati in 2017. And I cleared uh, 2000. I cleared CSR NET JRF exam in December 2019 with all India rank of 27. Sorry, 17. And I have cleared also CSR NET JRF exam 2019 June with all India rank 27. And I have cleared GATE 2020 with all India rank 72. Okay, sir. And with teaching, and I am guiding the regional student of Assam from only preferably from Assam. I am guiding student from Assam for various MSc entrance exam like CUET PG and for government state university like Guwahati University, Cotton University, Dibrugarh University. Up from 2021, I have mentored around 400 plus students and 400 plus students in these 4 years. Yes, sir. That is my intro. थोड़ा
Yes,
और मतलब अच्छा करना होगा. Yes, sir.
yes.
Yes.
Yes, presently good work from your side as a teacher and mentor in your state. Yes, no?
Yes, sir. Yes, sir. हाँ. Yes, sir. और एक बात पूछना था सर. मतलब मैं क्या है, जब मैंने टीचिंग यहाँ पे जॉब नहीं मिला था, तो मतलब एक गवर्नमेंट कॉलेज है ये अंडर ग्रेजुएट का.
Yes.
मतलब गवर्नमेंट कॉलेज, तो वहाँ पे मतलब गेस्ट लेक्चरर था. ठीक है. तो वहाँ पे मतलब मैंने पीजी को पढ़ाया था, अभी भी पढ़ा रहा हूँ गेस्ट एज ए ऑनलाइन ऑनलाइन करके पढ़ा रहा हूँ. तो वो भी मतलब इंट्रो में ऐड करूँ क्या? मतलब उसमें मैं फिजिकल स्पेक्ट्रोस्कोपी पढ़ाता हूँ और उसके बाद ऑर्गेनिक का ऑक्सीडेशन रिडक्शन पार्ट एंड देन कार्बन कार्बन बॉन्ड फॉर्मेशन जो होता है ना, वो भी पढ़ाता हूँ. माइकल एडिशन वगैरह, कार्बन कार्बन बॉन्ड फॉर्मेशन, वो नेम रिएक्शन, मिथनोबो वगैरह, फॉस्फोर जो कार्बन कार्बन सिंगल एंड डबल बॉन्ड फॉर्मेशन का जो चैप्टर है ना, ये सर.
Yes.
ये ऐड
वो
कर सकता
ज्यादा
है.
आप जैसे अपनी टीचिंग में करते हैं वही ज्यादा है, ज्यादा आप ज्यादा एक्सप्लेन करेंगे तो वो बहुत सारे क्वेश्चन हो जाएंगे. आप एक पार्ट टाइम बता सकते हो कि मैं अपने वहाँ लोगों को गाइड करता हूँ, इतना ये है, वो इतना सफिशियंट है. उसमें बहुत सारी चीजें आ जाती हैं. और भी बता सकते हो, अदर प्लेटफॉर्म अटैच है वहाँ पे, उसको भी करता हूँ हैंडल, तो वही ठीक है. क्योंकि ज्यादा रहता है तो वो बहुत सारे क्रॉस क्वेश्चन करते हैं, उनसे आपको ही प्रॉब्लम होगी.
ओके सर.
है ना?
लेकिन मतलब अगर मैं उसी उसी में मतलब प्रिपेयर होके जाऊँ तो स्पैम दूं अगर उन लोगों को, मतलब यहाँ पे ही मेरा होगा तो अच्छा रहेगा शायद. ऐसा तो
हाँ, वो अच्छा है, एक एनजीओ टाइप का आप चला रहे हो, बहुत अच्छा है। ये पार्ट टाइम ईयर बता सकते हो इतने टाइम से है ये वगैरह, बस इतना ही बोल।
हाँ, उतना ही बोलो ना। ओके सर,
उसकी
ठीक है।
पार्ट्स अलग हैं, उसकी और सारी ब्रांचेस हैं, बस ये बोल सकते हो आप।
यस यस, ओके सर।
तो आज आपने टॉपिक कौन सा किया है, केमिकल काइनेटिक्स?
हाँ सर, केमिकल काइनेटिक्स उस दिन बोला था आपको, मैंने पढ़ा था थोड़ा तो। मतलब अभी तो मैं पैरेलली बहुत सारा मतलब पढ़ रहा हूँ। मतलब इवनिंग मॉर्निंग में कॉलेज जाके ग्रीन केमिस्ट्री देख लिया, कलर पिगमेंट का थोड़ा, मतलब वो कलर पिगमेंट वगैरह भी पूछ सकते हैं, इसलिए मतलब नेचुरल है ना वो वगैरह। वो मतलब बाकी पैनल में भी लोगों को मतलब आता होगा शायद, इसलिए मैंने वो भी देख लिया। और थोड़ा ये अभी फोटो केमिस्ट्री लास्ट पार्ट देख रहा हूँ, मतलब वो जो क्वेंचिंग वगैरह है ना।
हाँ।
सर और एक बात पूछूं मैं, मतलब मैं एक डेमो के लिए कितना सारा टॉपिक मतलब प्रिपेयर करूं? एक एक दो तीन या एक ही मतलब काफी रहेगा?
नहीं, डेमो के लिए जो आपको मॉक दिया जाएगा उसमें वो चूज करेंगे, आपसे पूछेंगे। आप 5 टॉपिक कर लीजिए, सबसे बेस्ट है।
5 टॉपिक, ओके
हाँ।
सर। 5 टॉपिक, ओके सर, ओके। मैं आपसे बात में मतलब ये मैसेज में टेक्स्ट कर लूंगा, ओके सर, ठीक
हाँ,
है।
कोई नहीं। तो अभी हम केमिकल
ओके
काइनेटिक्स से स्टार्ट करते हैं। बेसिक, फर्स्ट ऑफ ऑल
सर,
केमिकल।
बोर्ड दिखाई दे रहा है ना? बोर्ड
यस।
बोर्ड इज ओके। और
यस
थोड़ा
सर।
मतलब यहाँ से
थोड़ा
ठीक
नियर
है
कर
ना?
लीजिए, थोड़ा दूर, डिस्टेंस ज्यादा है।
यस सर। हाँ सर।
यस।
यस सर।
Yes, let me start. The basic principle of chemical kinetics. What is chemical kinetics? And what the basic principle of chemical kinetics? Explain.
Yes sir. So chemical kinetics is the uh, determination of rate of a chemical reaction. From chemical kinetics, we can to know about the how the reaction proceed, and how at what time the reaction will end, and up to at what temperature it will the reaction times will double, the rate of the reaction will double. Yes sir. From chemical kinetics is the branch of chemistry where we discuss about the rate of the reaction, basically change of concentration of reactant with time. Yes sir.
Yes.
Okay sir.
What the difference between rate of reaction, rate law, rate of equation? Explain one by one.
Yes sir. So rate of reaction, basically suppose we are considering one reaction A to B. Okay, so here rate of reaction is basically change of concentration divided by time taken. Okay, time taken. So the concentration, change of concentration can be from reactant part, from product part also. Here rate of reaction means, since A is the reactant, so change of if suppose we are considering at initial time f time t1, concentration of A is equal to A1, and at time t2, concentration of A is equal to A2. So the change of concentration of A is equal to A2 minus A1. Okay, and change of time taken will be T2 minus T1. Yes. So for rate of reaction with respect to reactant is equal to change of concentration of A divided by change of time. Since the reactant concentration is decreased, so therefore we are putting here one negative sign. Okay, so we may write it as also A2 minus A1 divided by T2 minus T1. So that is the rate of reaction with respect to concentration of reactant. Okay, so again, what do you mean by rate law? What do you mean by rate law? Rate law is, suppose again we are considering the same reaction A to B. From rate law or law of mass action, the rate of reaction is directly proportional to the concentration of reactant with the power raised to its stoichiometric coefficient, with the power raised to its stoichiometric coefficient, that is rate of reaction according to law of mass action. Rate of reaction is directly proportional to concentration of A to the power, here the coefficient is, since here the coefficient is 1, so concentration of A to the power 1. Okay, rate of according to law of mass action, rate of reaction is directly proportional to the concentration of reactant with respect to the power of its stoichiometric coefficient. Yes sir, that is the main difference between rate of reaction with respect to change of concentration or time taken, or rate of reaction according to law of mass action. Yes sir. Suppose again we are considering another reaction, AA BB to CC plus DD. Here the rate of reaction with respect to this value is equal to minus 1 by A concentration of A by change of concentration of A by del T. Oh yeah, okay. And similarly minus 1 by B concentration of B by Vt, 1 by C concentration of C by T, 1 by D concentration of change of concentration of D by del T. That is okay sir. So similarly according to law of mass action, rate of reaction is concentration of A to the power A and concentration of B to the power B. That is from according to law of mass action, that is with respect to change of concentration with respect to time. Yes sir. Okay sir.
Good.
Which okay sir. Yes.
Next is what the uses of rate law, rate equation, rate reaction. Any one example?
Uses of rate law. From rate law we can determine the how fast the reaction will proceed. If we consider that is suppose we are considering A to B. Okay, so twice of A to 2B. Okay, so from rate of reaction is equal to constant K A to the power 2. Okay, we are considering the from law of mass action, rate is equal to K concentration of A to the power 2. Now if that is the initial rate of reaction there, so we are taking it as a rate 1. Okay, now if we double the concentration of A, okay, I am taking if we double the concentration of A, then the rate of 2, that means rate will change. How much it will change we can calculate from rate law. Rate 2 K, since we double the concentration, so K into twice A to the power square, so it will become K A square. That means 4 times of initial rate. From that is from rate law we can determine that how much rate will increase if we half the rate of the half the concentration of reactant. Yes sir, from that is the importance of rate law. Yes, is it okay sir? Okay.
Yes, good. Next, what is the difference between order of reaction and molecularity?
Yes sir, order of reaction is basically the experimental condition. Yes sir, order of reaction is basically experimental, and molecularity is basically the from we can calculate it from the reaction, only from reaction. Order of reaction can be it can be 0, it can be 1, it can be half, it can be anything, but molecularity cannot be 0. Molecularity should be 1, 2, 3. If the molecularity order can be from order is equal to experimental power. Okay, okay, then again I am telling one thing, which molecularity and order यहाँ तक ही याद है सर? Yes sir, up to this और 2-3 बात मतलब थोड़ा रुकने से याद आएगा. Order Molecularity. Order, yes. 1 minute. Order. Okay. Order. Order can be.
Order, yes, it's maybe fractional. It's
Yes,
maybe
sir. It
zero.
may be
It may be
fractional. It can
negative.
be zero also. Yes,
It's
sir.
alternate for the overall reaction. It is the sum of power of concentration terms which are shown in the rate law.
Rate law. Yes. And molecularity cannot be greater than 3. We can tell this also. Molecularity.
It's not
Yes.
theoretical value. It's not never fractional. It's never zero.
Yes.
It's always positive.
Yes, sir.
There's so many points. Yes.
Yes, yes.
First, go through on zero order reaction. What the main
Yes,
application of zero order of reaction?
main application.
Yes, zero order of
Main
reaction.
No, sir. ये तो पता नहीं है, sir. Main application of zero order reaction.
Application
Zero order.
limitation drawback.
हाँ, sir.
Mostly question from interview panel is application, drawback, limitation, disadvantage, and uses of our society.
Okay, sir. Limitation. तो zero order का application क्या होगा? Zero order from hydrogen and platinum surface. Application phosphorus. No, sir. याद नहीं है, sir. I am not.
कोई नहीं, मैं आपको
Zero order.
ओके
Okay, sir.
सारी जो
आप भेज
एप्लीकेशन
दीजिए.
वो आपको भेज
Yes,
दूँ.
sir.
तो
Okay,
जीरो
sir.
ऑर्डर को एक्सप्लेन कीजिए, क्या है जीरो ऑर्डर एक्सपेरिमेंटल, हाउ
Yes.
टू.
Yes. Yes, sir. Suppose we are considering one reaction that is reactant to product. Okay. So R to P here, since this is a zero order reaction, rate or minus the concentration of dr by dt is equal to k r to the power 0. Why this is 0? Because we are taking it as a zero order reaction. Now it will become minus of dr by dt is equal to k. Okay, so we are if we cross this, dr is equal to minus k dt. Dr is equal to minus k. So this is the equation 1. For again, for since this is just a infinitesimal sense, so for if we take integrating both sides, then concentration of dr is equal to minus integration of dt. Okay, so this will become r is equal to minus integration of dt. Since k is constant, k will come outside, kt plus c, and here c is the integration constant. C is integration constant. For integration constant, we can take that suppose at time t is equal to 0, concentration of R, that is concentration of reactant, we can take it as R0, and T is equal to 0. So therefore equation 2 will become R0 minus k into 0 plus c. So we are getting the value, we get the value of c is equal to R0. Okay, so from here we get the value of c is equal to R0, and putting the value of c in equation number 2, we get R is equal to minus kt plus R0, and minus kt is equal to 1 minute. We can take this as kt is equal to R0 minus R, and k is equal to rate constant is equal to R0 minus R divided by t. That equation or this equation is the integrated rate law equation for zero order reaction. Yes. That
Yes.
equation will be the. Okay, sir.
What's the half-life of zero order of reaction?
Yes, sir. What do you mean by half-life? Half-life is the time that half-life is the time where the concentration of reactant, initial concentration of the reactant become half. That is called the half-life. Okay. Suppose we are getting the integrated equation for zero order reaction is R is equal to integrated equation for zero order reaction is R is equal to minus Kp R naught. Okay, from here we can calculate K is equal to R naught minus R divided by T. At T is equal to T half. What I am telling, what I have told already, that initial concentration of the reactant will become half. That means R is equal to, that is final concentration of at T half, final concentration of R is equal to R naught by 2. So therefore K is equal to R naught minus R naught by 2 divided by 2 is equal to 2 of R naught divided by 2 is equal to T. So from here we are getting R naught divided by 2T half, or T half is equal to R naught divided by twice K. This will be the value for zero order reaction half-life of zero order reaction, that is R naught by 2K. Here R naught is the initial concentration of reactant and K is the rate constant of reaction. Here T half directly proportional to R naught. Yes, sir.
Yes, good.
Yes. Here T half directly proportional to R naught.
Yes, what the graph of zero order of reaction? Rate versus concentration, rate versus time, and concentration versus time. Explain.
Okay, sir. Rate versus time.
Rate versus concentration, rate versus time, concentration versus time.
Yes, sir. So for zero order reaction graph, okay, rate is equal to K a to the power 0. Okay, this will be the equation. So rate is equal to independent of concentration. So if we put that here rate and here the concentration, since constant independent of concentration, so rate is parallel to A naught and this value will be K. Is it okay, sir? Rate versus concentration. Is it okay?
Yes.
Rate. Okay, na?
Rate versus concentration.
Okay.
These graph is rate versus concentration. Yes.
Yes. Rate versus A naught. Yes, sir. And that value, that the intersection is K. Intersection will be K. Is it okay, sir?
Yes, okay.
Okay.
Next one.
Okay. So similarly, sir, for concentration versus time. For concentration versus time, here we are getting this is R. So R can be Y, that is Mx plus C. Here, this equation is in the form of Y is equal to Mx plus C. So here Y is equal to R and concentration is equal to time. So therefore, since the slope is in negative form, so the graph will be like this, and this is the intersection. The value is R naught, and the slope is minus f. Yes, sir. That is for concentration versus time. Yes, sir. That is for concentration versus time. Okay.
Yes. Good. What the example of zero order of reaction? Any reaction example?
Yes, sir. So example of zero order reaction is decomposition of ammonia on platinum surface is the most important example of zero order reaction, and hydrogen and bromine, I think. reaction of hydrogen and bromine. Is it correct?
Yes.
Hydrogen and bromine. Yes, sir. Formation of hydrogen bromide from hydrogen and bromine molecule is the example of zero order reaction. Yes, sir.
Yes, good.
Yes, sir.
Next question is, what the relation between a pseudo order reaction and first order of reaction?
Yes, sir. Pseudo order reaction is basically pseudo first order reaction is basically the reaction where the reaction can be the reaction should be first order, but no, sir. The reaction should be first second order, but it can to wait. If the sorry, how can I explain? Okay, so if we take two reactant molecule and one reactant molecule is in excess amount, the concentration of that reactant molecule will does not affect that rate of the reaction. So only depend on that the reactant which is taking only depend on that reactant which is taking only little amount. So the excess reactant will does not affect the rate of the reaction. So it can be it should be second order, but due to it does not, since it does not depend on the reactant which is taking in excess amount, so therefore it become first order reaction. So we can call it as a pseudo first order reaction. One example of pseudo first order reaction is hydrolysis of ester. Here ester is we take ester is in small portion and the hydrolysis, that means water is in excess amount. So water does not affect the rate of the reaction. So therefore this reaction is we can talk it as a pseudo first order reaction. Okay, sir. Only and first order reaction is only depend on what is it? Only depend on one reactant concentration. So therefore it is called first order reaction. Yes, sir. Okay, sir.
Yes, good. Basic difference. Yes. Next,
Yes,
move
sir.
on. Briefly discuss about the first order of reaction. Explain.
Okay,
Application
sir.
of first order of reaction.
एप्लीकेशन तो याद नहीं है आपको पूछना पड़ेगा सर.
Yes. Explain.
Yes, sir.
Yes, I will
So,
send.
first order reaction. First order reaction. Yes. For first order reaction, again, I am taking the same example, reactant to product. Here, the rate of reaction or change of concentration of minus dr by dt is equal to rate constant concentration of r to the power. Why it is 1? Because this is a first order reaction. Depend on the power of concentration of reactant to power of 1 only. Okay. So here again I am taking, since here it is concentration term, I am taking this concentration term to left side and time to the right side. So integrating both side dr by r, integration of k dt with yes. So integration of dr by r is equal to ln r or minus kt plus c. So c is the integrating constant. For determining the value of integration constant, we are taking at time t is equal to 0 and reactant concentration is equal to r naught. So equation 1 become ln r naught is equal to minus k into 0 plus c. Okay, so c, we get the value of c as ln r naught. We get the value of c is equal to ln r naught. Now putting the value of c in equation 1, so ln r is equal to minus kt plus c ln r naught. Okay, so kt is equal to ln r naught minus ln r. So KT is equal to, since ln of B minus A, so that one. Okay. So K is equal to 1 by T of ln R naught by R. Yes, sir. K is equal to 1 by T of ln R naught by R, or for this is the, since it base is T, for log 10 base, we can take it as 2.303 by T log of R naught by R. Yes, sir. Okay, sir.
Yes. What the graph of first order of reaction, rate versus time, concentration versus
Yes,
time?
sir. For first order reaction, this reaction is rate is equal to K R to the power 1, or we also know this reaction is A is equal to concentration of A or R is equal to R naught. From here we can get it as e to the power minus KT. Okay, so rate is actually, if we draw a graph between rate versus time, this graph will like this. This is the never ending graph for rate versus time for first order reaction. Yes, sir.
Yes.
Is this okay? Yes, sir.
Yes. What the relation between first order of reaction and radioactive decay? What the relation?
Yes, sir. Sir, radioactive decay is a radioactive decay follow first order reaction. Yes, sir. Radioactive decay follow first order reaction. That is also a never-ending reaction. And here from here we can get it like. So what can I tell here? Only radioactive decay is a first order reaction. I can tell that only, or any other thing, sir.
Yes. Example of radioactive decay. Radioactive
Example
decay.
of
Yes, sir.
example of radioactive decays are decomposition of uranium to lead and tin. Similarly, decomposition of neptunium series. Yes, sir. Neptunium also. Yes, sir. Sir, I think I have to read that also. 4n plus 2, 4n plus 1. That
Yes.
4n
Yes.
plus
Yes.
2 series. Yes, yes. I have to read that thing. Oh, radioactive part. Yes, sir. Okay. Yes, sir.
Yeah. Next point is, what the example of reaction is first order of reaction? Any example?
First order reaction to, sir, I am told already radioactive decay process, and I am not remembering it actually. First order reaction, 1 minute, sir.
SN1 reaction is first order reaction.
Yes, sir. Yes, sir. SN1. Yes, sir. Yes, sir. Presence of mind. Yes, sir. SN1 reaction. No, sir.
Yes.
Okay. Okay, sir. Okay. That means I have to tell that reaction of tertiary butyl bromide with aqueous potassium hydroxide is a first order reaction. I have to tell like that only.
Yes.
Yes.
Decomposition of N2O5, inversion of cane sugar.
Yes, sir. Decomposition of N2O5, PCl5 with acid.
Yes.
No. Yeah, PCl5. Yes, yes. Okay, sir. Yes. ठीक है, sir.
Yes. Next order of second order of reaction. What the main derivation as
second
order of reaction?
second order तो सर इतना तो ये तो नहीं कर पाऊंगा शायद. ये तो second order तो no sir. I will no sir. ये तो नहीं हो पाएगा second order. मतलब इतना दूर तक नहीं.
इतना दूर तक नहीं पहुंचे. What the half life of first order reaction, second order reaction? Explanation.
Yes, sir. Sir, for half life of first order reaction, since we know that K is equal to 1 by T ln A naught, initial concentration of A, final concentration. So for T is equal to T half, concentration of A will become A naught by 2. Final concentration of A will become A naught. Initial concentration of half of initial concentration. So K is equal to 1 by T ln A naught divided by A naught by 2. So 1 by T half. Wait, I can take this as T half is equal to 1 by K ln 2. So ln 2 value is 0.693 divided by K. So for first order reaction, T half is basically 0.693 divided by K for first order reaction. And for second order reaction, though I am not remembering, T half for second order, 1 by e to the power n minus 1. A naught to the power n minus 1.
T half is equal to A upon K2A.
Yes. K to A naught. Yes. So K A naught. 1 by K A naught. Yes, sir. That is for second order reaction. Yes, sir. Okay. So for this. Okay, sir. Yes. For here, for first order reaction, T half is independent of initial concentration, and for second order reaction, T half is inversely proportional to initial concentration of reactant. And for zero order reaction, T half directly proportional to the concentration of reactant. Yes, sir.
Yes. What the unit of zero order, first order, second order unit?
Yes, sir. For zero order reaction, unit is mole per liter per second, and for first order reaction, that is second inverse, and for second order reaction, liter mole inverse second inverse. Yes, sir. That is for zero order reaction, and that is for first, and that is for second. Yes, sir. Mole per liter per second, second inverse, liter mole inverse, second inverse. Okay, sir.
Yes. What the uses of zero order, first order, second order in a real life human being? Any example? One by one. Explain.
First order reaction. याद नहीं है. जीरो ऑर्डर का नो सर. ये मतलब एप्लीकेशन वगैरह मुझे आता है, मतलब ये तो देखा ही नहीं. मतलब कल भी मैंने परसों मतलब एक टीचर को मैंने पूछा था, उन्होंने भी बोला कुछ कुछ ऐसा पूछ सकता है. वो मतलब यूनिवर्सिटी का टीचर है, गुवाहाटी यूनिवर्सिटी का.
पूछ नहीं सकता.
पूछेगा ही.
ये ऐसा ही जितने इंटरव्यू होते हैं आपने देखे हैं बीआरसी और इनके इन सब में, ये जितने स्टूडेंट है ये क्या पढ़ते हैं? एमसीयू क्वेश्चन पढ़ते हैं. डायरेक्ट काइनेटिक्स क्या है, फर्स्ट ऑर्डर क्या है, बस ये पढ़ते हैं. उसके जब क्रॉस क्वेश्चन करते हैं ना, वो आते नहीं इन्हीं को. तभी तो आप देखते हैं ना बीआरसी में सबसे कम सिलेक्शन होते थे, लेकिन अब इस बार सब रिकॉर्ड टूट गए.
हाँ सर.
तो इस तरह से क्वेश्चन वैसे मैंने आपको भेजे हुए हैं रियल लाइफ में बहुत सारे, आप देखोगे तो बता सकते हो. जैसे आपने बताया था अभी डिकम्पोजिशन ऑफ अमोनिया, ये भी रियल लाइफ में यूज
हाँ.
होता है. हेबर प्रोसेस है, ये भी रियल लाइफ में यूज होता है.
यस सर. हेबर प्रोसेस. हाँ.
होता है ना रियल लाइफ में.
हेबर प्रोसेस. यस. यस. मतलब यही. और सर एक बात पूछना था फोटोकेमिस्ट्री का. मतलब एक फोटोकेमिस्ट्री का तो कुछ कुछ तो ये वगैरह केमिलुमिनेंस वगैरह तो रियल लाइफ में फोटो ये जो मतलब रास्ते में जो होता है ना
तो हम
फोटोकेमिस्ट्री का.
डिस्कस कर लेंगे, कोई दिक्कत नहीं. फोटो केमिस्ट्री हम जो ऑर्गेनिक और फिजिकल दोनों डिस्कस करेंगे तो वो सारी चीजें आ जाएंगी. और इस टाइम 1 2 ऑल्सो फोटो केमिकल है तो फोटो लाइट के अकॉर्डिंग हम डिस्कस करते हैं. वो आगे टॉपिक आएगा तो उसको सब डिस्कस कर लें. अभी हमारा टॉपिक है केमिकल काइनेटिक्स, तो इसको डीपली स्टडी कीजिए. बाकी जो बेसिक चीजें हैं वो मैं आपको भेजता रहूंगा, है ना. बाकी डेरिवेशन वगैरह सर बढ़िया है, आपने अच्छा किया है आज. इस तरह से हम डेली करते रहेंगे, अब डेली कंटिन्यू रहेंगे, ठीक है ना.
हाँ सर. कल भी मतलब कंटिन्यू रहना होगा, नहीं तो मतलब नहीं होगा सिलेबस खत्म.
अब डेट आने वाली है.